This is the Digital Factory podcast. I'm John Brunner. Last week, a large part of the additive manufacturing industry was in Frankfurt, gathering at Formnext, which is an immense 3D printing trade show. In this episode of the podcast, we'll bring you 3 quick interviews with some of the people who were there, including Joris Peels, the editor-in-chief of 3dprint.com, Nora Toure, the founder of Women in 3D Printing, and John Hart, a professor at MIT and the co-founder of Desktop Metal. Before we get into the interviews, though, a quick reminder to read the Digital Factory report if you haven't already. This is a paper we put out this fall that covers advances in artificial intelligence, factory automation, and 3D printing, and takes a look at how those technologies are changing the way that the manufacturing business works. You can download the Digital Factory report for free at thedigitalfactory.com. And now we go to the hallway immediately outside of Formnext for the interviews. So I'm joined today by Joris Peels, who's the editor-in-chief of 3dprint.com. It's great to have you with us.
Thanks. Great to be here.
So we're at Formnext. We're looking at a lot of the progress that's happened in the 3D printing industry. All of the big companies are here. As the editor of 3dprint.com, what are you interested in? What have you seen that's intriguing?
Well, I think there's certain trends, some big trends that I really applaud. I'm really happy to see. It's like post-processing equipment, for example. It used to be just like this one little pathetic stand in the back. And now it's getting, people are getting up with more integrated solutions. You've got like stuff like AM Flow is looking at scanning parts to figure out what part it is. There's automated post-processing equipment that, for example, like completely depowders metal parts in 3 different steps in an automated way. Like as much as like 30% or more of the cost of a final 3D printed part is labor. And a lot of people forget just how much manual labor is in these parts and how much of these, how much of the cost is encapsulated in them, and how important it is that the things you do in post-production, especially with metals, there's a lot of steps you have to do. And to see those kind of companies here and to see those kind of companies invest in booths and bringing people here means that it's serious about production, right? Anyone can sell, like a couple of years ago, we were selling metal machines, like 100 a year or something, mainly to universities. It was like metal printing, it's the future of aviation. Meanwhile, it's some guy at a university tinkering with it, doing like 1 part a week and then doing it in all sorts of exotic settings and materials. Now, it's the time, it's like I call it like the clipboard time. It's like the time of the ISO implementation. It's the time of like checklists and things like that. And you're seeing, because before you can always sell a metal machine to a university. Now we're selling to a car manufacturer.
And is that actually happening? I mean, I walk around and I notice that every single company has a metal 3D printer, a big DMLS kind of thing. Mm. Are they actually selling these?
Yeah, they're selling a lot of them. So the sales of these things have gone like from, let's say, around 100 to around 1,000 a year. It depends what you class.
You mean across all the manufacturers?
Across all the major manufacturers. It depends on if you're looking at selective laser melting or DMLS or whatever it's called, this or powder bed fusion or laser powder bed fusion or whatever you call it this week. So around those systems, you're seeing around 1,000 or more being sold. Depends on, and there's also smaller systems. There's indirect, and there's also kind of like the binder jetting systems being sold as well. But think of around 1,000. And considering the fact these things start about 300K and go up to usually like before you've made your first part, you're going to spend about $2 million or something on all your post-processing equipment and the room and all this other stuff. So it's a considerable investment. And where they're going now is 2 major areas. One is aviation. Aviation is investing very heavily in qualifying parts, qualifying materials and processes for AM in aerospace. So we're talking the rocketry part is really heavy, rocketry in space. Also missiles, other things of that nature, missiles and satellites of the military. And then also military aircraft, and also now civilian aviation. So this is a really burgeoning area where we're seeing that the battle is already won or lost for a lot of these guys behind the scenes by certain companies like Honeywell and suppliers tier 1, 2, and 3 standardizing on a certain bit of equipment. This is also one of the underlying logics behind GE's acquisition is to commercialize this for U.S. aviation industry and the U.S. space industry. Because now U.S. companies are patent holders of the EBM technology and DMLS, which they weren't before. Mm-hmm. So now the U.S. can offer an integrated solution for the first time, powder, machine, and the patents in all being American. And that's really important since so many of the parts of their military aircraft and drones come from 3D printing.
Right.
So aviation is really big, and what is emerging now is car companies. So the first parts are being made already in some limited mass customization like numbers, so in the actual passenger vehicle. And on top of that, we're seeing customization of parts, like for example, Mini, and we'll be offering that. Mini's doing this with Twicket, I think.
And they're doing customized plastic parts, right? Not customized metal parts?
Yeah, polymer. Metal customization is actually really difficult with DMLS because of the predictability. So one of the problems with DMLS is that it'll take you 3, 5, 6 parts to get to your first part. Mm-hmm. If you want something that looks like an acetabular cup, one of these hip cups, perfect. But if you want a completely new thing, it would be really difficult to make. So new things are really difficult to make in DMLS. Once we've dialed in that design space, we can make a million things or whatever, really high repeatability. If you would want to offer metal customization through DMLS, you would have to qualify for, and at the moment actually print parts out for all these different variables, which would be cost prohibitive for most applications. So that's why simulation software is so super important in this space. And it's nice to see those kind of guys coming in, Ansys and these kind of dudes come in and really try to solve that simulation challenge, and Materialize is also trying to do it as well. And kind of things like automating support, structure generation, and stuff like that can really make a lot more of these business cases possible. So in cars, it's right now what we're seeing is high-end cars customization. So think of like the custom Rolls-Royce or Bentley type automobile, the one-off cars as well, like the Pininfarina. When you hear some guy who gets his car made for Pininfarina, prototypes of course, and then now we're seeing mass customization in vehicles. We're talking about like limited small choices. So think of really unpopular mass customized parts. Mm-hmm. They're looking at those, and also people are looking at kind of like the more like your name on your steering wheel kind of thing. Although the steering wheel is a bad example, but your name on the part kind of thing, or your customization. So that's happening, but it's a way for them to introduce technology. Because for them it's really important to save weight. With electrification, it gives them opportunities to introduce new technologies. And also to rethink how things are made, and to rethink, are we going to farm out the car to 10 different manufacturers where there's a guy making a part that's like 9 steps removed from us? Is that what we want? Is that the supply chain we want? Or do we want to do something, everything in Germany?
So the two applications for metal 3D printing that you just mentioned in aerospace and in healthcare with implants and medical devices, those are very high value kind of exotic niche applications for metal 3D printing. Do you think metal 3D printing has a future in kind of like the mid value space, like in the automotive industry?
It would depend on. So I'm really skeptical about binder jetting. I'm much more skeptical about binder jetting metals than other people because of shrinkage rates and predictability on shrinkage. I think it's going to be really difficult across parts and sizes and wall thickness, especially with changing wall thickness. We're going to have to come up with a lot of software and a lot of compensation and a lot of testing actually is going to have to be done in order to figure out like just what the shrinkage rates would be at every wall thickness, at every size, not every geometry, but a lot of different geometries. So that to me is a really inhibiting factor to binder jetting metals. I think I would be much less positive about binder jetting metals than the manufacturers have hitherto been. So I think that's going to be a much more difficult challenge to them. If we look at a couple of other industries that for decades have been trying to make metal parts in similar ways, then they have had difficulties with these shrinkage problems for as much time. They've put billions in research and some of the best metallurgists ever into this industry for decades, and they haven't been able to solve it. Now, I'm a really cool startup. We got X million. It's not all of a sudden going to make it like that. You, bam, are going to be able to solve this.
Right.
So I'm less positive about that. I think one technology that is really interesting is, for example, indirect with casting. That's actually a really interesting technology to do that in an automated way, but you would have to automate more steps as well. There's too much manual labor involved in that, and I don't see at the moment how you could, in an easy way, for example, do support removal for SI in an easy way. But I think if that's a challenge that can be solved, then indirect is a really good path forward to car parts. In the long run, perhaps they'll solve the shrinkage problems, so then binder jetting would work. If you're talking about like any kind of enclosed build chamber process, like the DMLS type processes, SLM, you're always going to have the cost. Your machine is always going to be ridiculously expensive because titanium likes to
explode,
catch fire. There's a lot of reasons why that build chamber is going to raise the cost of your machine. Now, add up, for example, they've kind of figured a way to radically reduce the cost of the machine by isolating just this one build chamber and keeping the rest of the machine kind of cheaper. So that's a really interesting path forward. But I don't really see an option of making a really reliable, safe DMLS machine that would be a reasonable amount of money. Now, that's not an inhibitor, right? The inhibitor is really in the post-processing and the many steps it takes, the many things. There's a guy lifting this part in and out of a machine like 4 or 5 times. This is ridiculous. It's never going to work. There's a guy cutting these things off by hand. That whole chain has to be automated. For DMLS to work, that whole post-production chain, like depowdering, destressing, HIP or CNC or whatever you want to do, it has to be automated. And then, but then you're looking at costs like we see right now. The dental guys are kind of like destroying each other at the moment. What you see right now is that you can, if you're going out of business, you can totally get like a low-cost part, right? So it is possible. But at the moment, I mean, what we're seeing is that, there are limits there because of the high labor component involvement and the high investment. So that's going to be a problem. Now, is somebody going to come up with a completely new metal technology? Perhaps. And another option as well is everybody's always thinking of the fine mechanical parts, like the DMLS parts, which of course make a lot of sense for small aviation engineering parts and in the body and in aircraft. But think of like some of the larger scale technologies, the cladding technologies, which have been used in really large parts like wing spars for years now, and in test aircraft and prototypes in kind of like these X aircraft.
By cladding, you're referring to? No,
laser cladding is that's kind of there's a whole bunch of group of different technologies. You can call them directed energy deposition. I think that's the official term, but they're known out of like all their different kind of constituent parts. But these are like technologies. It's like cheese whiz for metal, kind of. And some of them work with you're spraying a material. Some of them work where you're taking a welded wire and you're atomizing it. And there's a whole different technologies. Generally, they're welding technologies that were used as far back on like the space shuttle and stuff like that in the 80s and stuff, and even before in some cases. And there are a bunch of welding technologies. The guys said, okay, wait a minute, we'll put a motion stage on it and we can make it go up, right? Or another motion stage and make it go up. Oh, that's kind of like amazing. And then so that kind of 3D kind of stuff is like been commercialized for a whole bunch of different people. Like a good example, at Trumpf, for example, they have 2 technologies. One is a DMLS one. The other one is, they have these laser cell technologies. They cut stuff. They can weld stuff. Well, why not put a motion stage on it?
So that's appealing because it's an adaptation. It's a 3D printing adaptation of an existing process that these companies are familiar with, that they've qualified in different ways.
To a certain extent, yes. But it's also cost-wise. What happens is we have much higher deposition rates. Where you're seeing the cheese whiz thing is kind of like, if you see it, you'll know it. And this totally does look kind of really, really rough. You're like, well, how are we going to do this? And then either via casting or via CNC, you have to smooth that part down again. So you have to compensate for that. But then you can make large structural parts. So you can make something like a couple of meters, and in a much more controlled way than you would be able to if you put a welding head on a robot arm. But that's also another way of getting there. But and in part you can do that repurposing existing equipment. So you can use your existing CNC, or you can use your existing laser to do this.
Or you could have a CNC integrated with one of these deposition printers,
exactly.
Which you kind of see in these enormous machines from Trumpf and others.
So these are the really big ones are like and that you can make an entire car like a frame for it, right? And then you're thinking, wait a minute, the design freedom that would give, and the amount of labor that would save on welding, and the amount of interesting things you could do with that for a car to make like an integrated frame kind of thing, or like a monocoque kind of chassis kind of thing. out in one step. That's really exciting.
So this is the exciting thing is how huge this can be, right? It's not like a DMLS where you're limited to, a few inches by a few inches.
Yeah, well, DMLS is like 40, 50 or something like that. But yeah, the build volumes, but then it's getting bigger. But then the machine will just increase in complexity and cost so much. So this is a process a lot less accurate. You can't make a lot of the textures. You can't make a lot of the things with it. But yeah, it's a relatively low cost. Now the other interesting thing is that the feedstock is also really, really low cost. So for DMLS, you need powder that's really, really round, but not like super duper round, or like the roundest like 38 micron powder you can get in the world, but then a little bit different, right? Mm-hmm. So. And there's hundreds of vendors of powder at the moment entering the market. Very few of them have been able to make like powder that works well in DMLS, and that leads to all sorts of problems if you would use it. So this powder is sold at an inflated rate, as opposed to, you're talking like, it used to be, it's really funny, it used to be 860 a kilo for titanium, which is hysterical. And and then it went back down to like 500-600. And then Arcam started selling about 170 or something a kilo. Everybody's like, oh my God, 170 a kilo. Right, and so now it's much lower. But these feedstock materials for the directed energy deposition processes are just like really close to like the extruded wire.
What you would buy at a welding supplier.
Yeah, exactly. It's the same kind of stuff for a couple of bucks. And then all of a sudden, that's when you get the car guys interested. And they're like, oh, wait a minute, that makes sense. Right?
Interesting.
And the funny thing is on polymer, there's polymer parts now that are 300, 400 a liter or a kilo, right?
Yeah.
So we're still ripping ourselves off. And I think we're shooting ourselves in the foot because we're artificially reducing the number of business cases that can successfully be made with 3D printing just because of the high price of the polymer.
Yeah, so it's like the field hasn't stabilized at all then. It's continuing to develop really quickly, at least cost-wise, sort of implementation-wise.
Yeah, totally. I mean, I think the interesting stuff is like the boring stuff.
Yeah.
That's what really gets me excited is the boring stuff where they're saying like, we made 1,000 of these, or we're doing a Six Sigma, whatever thing with it, or like DSM had this really thing which I didn't understand. They came up with this press release which was like completely confounding. I was like, DSM adds 2 materials to the DigiMat. And I'm like, what the hell is this? I'm like, what am I doing with this, right? So, and then I looked at this at their stand the other day, and what they've done is really I was not familiar with DigiMat, I'm sorry. And they've made this thing that they've tested the part and input it in their database system so they can now predict failure in the part. And they can now go to a car manufacturer and say, look guys, this is what's going to happen if there's too much stress on this part, or this is what's going to happen. So that's really exciting to me, because that means that some guy at some large manufacturer can say, hey, I would like 10,000 of these. Mm-hmm. And like for stuff like clips, right? For clips, for little difficult parts in the engine, they can make materials now for engine bay kind of usage, that kind of temperature. So then you're talking about like, we're going from tens of thousands of standardized parts. And they're also doing this kind of because they want to, and they want to kind of get familiar with it. But at the same time, that's unlocking doors. You can't ask an automotive manufacturer to take a leap of faith, right? You can't ask a guy making an air engine like, oh, it's hope for the best. It's ridiculous. You need to give these guys data, and you need to give these guys a comfortable space.
Yeah.
So it's kind of like that kind of stuff that I find myself having to look double at that kind of press release and think, oh, wait a minute, what do they mean by this? And why is this so exciting for them? Mm-hmm. Because otherwise, the other 10 press releases I got are like, world changing 3D printer. And then you're like, where's the world changing exactly? And the world changing is like in the forms and in the qualifications of parts and in approvals, FDA approvals and things like that. It's the boring stuff.
I'd like to change topics a little bit and ask you the question I ask every guest on the podcast. Tell us about your favorite tool.
It depends. I mean, I don't know. Tool always makes me think of hand tools. So then I always have this Vera Joker wrench thing, and it's like, I love it. The texture of it is really nice, and it just like makes me want to take things apart, put them back together, and take them apart. And I'm like, sometimes I stand and holding it, and I'm like, oh, I don't have a use for this, And I have a Vera precision like screwdriver set. I love that as well. I think those are my favorite like hand tools. Yeah, there's Viha has them as well, and there's these ones from Phalo as well. So it's a really big thing of trying to figure out.
PB Swiss and
those are really nice as well.
Yeah, I have a set of those. They're the most extravagant thing I've ever bought.
Yeah.
I mean, if you just look at the difference between the cost of the PB Swiss drivers and the cost of like any completely adequate driver that you could get on Amazon.
No, but I think this is the thing you buy for life, right? It's the thing that you can use forever if as long as you don't lose it, right? Yeah, that's the only thing. So I love the PB Swiss ones as well. Viha is nice, Vera, and I have like I do tool porn. I have like a set and gold. No, it is stupid, and I know, but except for the precision screwdrivers, which of course you use a lot in 3D printing to adjust stuff. Those I use a lot, but yeah, if I'm honest, like at the moment, like the big tools or something, I need that to be a bigger part of my life at the moment. I need to like start doing more.
Get them back in your hands.
Yeah, exactly.
It's been a pleasure to speak with you today. If listeners want to read what you're writing, where do they go?
Just 3dprint.com. So we post 8 news stories a day on average, or a weekday, and we're trying to really bring good journalism to 3D printing. So we're doing stuff like fact checking, and we're actually 3D printing people using 3D printing knowledge to weed through all the bull that we get to really give you really good, high quality, checked, analyzed articles with good information in them. So we really hope that we'll be like your daily news source for all the good stuff you want to know about 3D printing and the stuff you want to learn for the industry. So we'd love for you guys to check out 3dprint.com.
Great. I read it all the time. Joris Peels, editor-in-chief of 3dprint.com. Thanks so much for joining.
Thank you very much.
So I'm here with Nora Toure, who's the founder of Women in 3D Printing. Thanks so much for joining us.
Of course, thank you.
So what's the big interesting trend right now in 3D printing that you're thinking about these days?
Yeah, so something very interesting is happening. And I think it's actually happened since the early 2000, even like maybe 2005, is that I think we're seeing democratization of technology, but that's going beyond 3D printing and additive manufacturing, actually. So, for example, when I created the blog Women in 3D Printing, even though I'm not a software engineer, even less a developer, it took me an hour to build the website just because I used WordPress. So, it can take 5 minutes to someone a little bit more tech-savvy than I am, but it took me an hour. And that's actually something just like similarly we seeing the same things in additive manufacturing. So you have more and more online tools that enables anyone to just access the technology. So what it actually means is that you do not need to be an engineer to 3D print today. All you need is to have a good idea, have access to platforms where you can either learn about 3D printing, or if you don't even want to know anything about the materials, you can just choose a service bureau, and you don't even have to know about the materials itself. You just have to know, like, okay, this is about like what I need. Place your order, and a few days later you get your order, and that's it. And then you have your part. And then, of course, you have still to do assembly, so there is still, a lot of things you need to do down the line. But the actual tools of 3D printing, it's really easy to access it.
So everything is becoming more accessible to sort of generalists.
Yeah, of course. Yeah. And I think that that actually means that you have more diversity in 3D printing. And again, I think this is true for 3D printing, but it also will be true for other technologies. When we look at the numbers, it's an average of 11% of female engineers we have globally. So, of course, it varies from countries to countries, but even if the countries with most women engineers, it's less than 20%, so it's still bad. But even though, again, I'm no engineer, and still I'm a user of 3D printing, so I would qualify as a 3D printing industry user, even though I do not qualify as an engineer. So that for me is really an interesting trend. That's something that's happening right now.
Thinking of the women who are members of your community, how did most of them enter the 3D printing space?
So usually from their own specialties and their own industries. So we have, and that's case for men as well, like the people who are using 3D printing with actual applications for 3D printing, they're using it as a tool. So for them, it doesn't really matter it's 3D printing or CNC or whatever else. They're using it really because they need it in the moment to do something. So fashion designers might be using it to build some new pieces just because they got the idea of something innovative that they cannot do otherwise. Healthcare 3D printing just because it makes just so sense. Aerospace, same thing, like you're going to use 3D printing as a tool. So yeah, people are really coming from the specialty of their industries. And then they start, changing our industry because they're innovating in there. And something that a fashion designer is working on today could actually be useful for someone in aerospace or in healthcare. And again, that's really, to me, the beauty of this industry.
So it's an accessible set of technologies that are relevant to a wide range of people, and so it's becoming a more diverse community?
Absolutely, yes.
Thinking from the perspective of employers in the 3D printing field who want to attract a more diverse workforce and want to strengthen their employee base, what do these companies need to do to appeal to more kinds of people?
Well, I think the first thing they need to do is to stop looking necessarily at the degree people have, and more like the willingness they have to learn about something new. Because again, there is no 3D printing degree just yet. There are like minors in engineering fields, but you don't have a major of 3D printing. So no matter what, you're not going to find an expert in 3D printing coming straight out of school, even though that person might be qualified on learning. And I think we're all qualified in learning. So I think it's more like looking into the actual characteristics of the person willing to learn something new, being interested in manufacturing, being interested in technology as a whole, and then give it a shot. And, give it a shot. I think that's my best advice.
So I'll ask you the question I ask everyone on the program. What is your favorite tool?
So on top of my mind, I would say WordPress. I know it's not a 3D printing related tool, but it's actually the one tool that enables me to have a voice in this industry and to build the Women in 3D Printing platform. And by this way, to actually enable other women to have a voice as well in this industry. And again, because it's so easy to use for me, like I don't have any chairs in, in WordPress, but it's really the tool I'm using every single day for Women 3D printing. So that's what's coming to my mind right now.
And it's representative of the kind of democratization that you mentioned earlier, where anyone can do this kind of thing, just like anyone can get into 3D printing from any background.
Absolutely, yes. Totally right.
If listeners want to find out more about what you're doing and read what you've written, where should they look?
Sure, womenin3dprinting.com.
Excellent. Nora Toure, thanks so much for joining us.
Thank you for having me.
I'm here with John Hart, who's a professor of mechanical engineering at MIT and is also co-founder of Desktop Metal. John, it's great to have you on.
Great to be here. Thank you.
So in addition to all of your other work in 3D printing, you've also been developing a curriculum for 3D printing at MIT. What's that about?
Yeah, that's been a big focus of my last 5 years at MIT, and in particular the past year. In the past year, we've focused on building a professional online training program for additive, but that dovetails really nicely with our on-campus programs, teaching manufacturing processes broadly, as well as focusing on additive for advanced undergrads and grad students.
And what's the key challenge with additive? I mean, why does it need its own curriculum?
So number one, as other people say, I think it's teaching everyone to think differently, right? To remove the constraints that we enforce when we teach about machining and injection molding, and think more about the functional objective of something, and then work yourself back to what the real constraints of the manufacturing process are. But sort of, in other ways, envision that design freedom.
So it's an entirely different engineering mentality?
Yeah, I think it's a rethink in a way. That's the word I like to use. It's, you know, at the end game, I think the real impact of additive is not just being able to produce objects digitally on demand that have funny exotic shapes, but rethink the entire process by which a product goes from the first concept to the last car on the road, if you will.
We talk on this podcast a lot about how 3D printing can turn manufacturing from being a design constraint into being sort of a design inspiration. So is that what you're aiming to do?
Yeah, right on. And I really feel like the things that additive will be used most abundantly for are, at least for me, like beyond my imagination. And when you talk to a designer who's, say, working on automotive interiors or fashion, you realize like this thought process of creative design and how at its core, additive enables them to think creatively in new ways. Yeah.
So I'm curious about the mindset of the students coming in. These are, young people who have only really known the engineering field in an era when 3D printing is a practical, effective technology. Do you see a different mindset in them?
Yeah, right on. So as you say, if I ask my room of 75 juniors in mechanical engineering at MIT who's used a 3D printer before, obviously everyone puts their hand up. They just think of 3D printing as a tool available to them, and in some ways it's a shortcut, right? I can 3D print it so I wouldn't machine it, but in other ways you see them think about consolidating parts into fewer parts, or coming up with little functional gizmos like fixtures for helping them paint their yo-yos, which is our project in our core manufacturing class. In terms of professionals, right there, of course you have the mode of the audience is educated in traditional manufacturing, but there the awesome thing is the expertise, right? Because everyone knows their field so well, and when they see the light of additive, even just desktop 3D printing, all these new ideas and creative solutions pop out, and you see the excitement when they're able to connect the dots. And I think that's what we can really leverage in the existing engineering workforce, is tap that true expertise, and it's just about connecting what additive can do to that expertise they already have.
So your course draws students from across the university, right? From the business school and from other engineering departments?
Yeah, so our on-campus AM course at MIT, mechanical, materials, electrical engineering, many business students interested in manufacturing and operations, and others.
So is that different? I mean, do you see that kind of cross-disciplinary appeal in other courses that you've taught, or is 3D printing unique in this respect?
Yeah, by far it's the most cross-disciplinary interest I've had, and you get say for instance students doing their MBA. Some actually come because they want to learn the mechanical engineering, learn the machine design, and others want to do the economics. So there's really nice push and pull between them and the engineering students, and in the end I like to put them on teams together, right? Get a spectrum of expertise and let them learn from each other.
Yeah, we talk a lot also on this podcast about the need to really think about 3D printing as something that can transform a product or transform the way that you do business, not just replace an injection molded part, right? So that's what this cross-disciplinary engagement is about.
Yeah, right on. And actually doing the online professional course in the past year has led me to really think of the whole field that way. Transformed how I look at additive. My upbringing is I'm an engineer. I think about machines and materials and the finest level of detail in the printer. But really it taught me to step out and look at the big picture and look at this rethink, right? In a way, I love manufacturing. Manufacturing is amazing. It contributes to so many aspects of our daily lives. But if I step back and think about it, it's fundamentally inefficient. Right? Think of what it takes to get a part made and all the effort, not only the engineering but the sourcing and the traveling to the supplier. And when you look at why most of the successful consumer industrial products need to thrive at such high production volumes, it's because all that goes into standing up the manufacturing. So I say rethink because we can really start to rethink how you go through product development. And it's not to say that 3D printing is going to replace the processes that we know and love, but it augments the capability at all points.
So you're someone who has one foot in industry and one foot in academia. Do you see any developments coming out of the deep research side of 3D printing that you think are going to transform the industry in the next few years?
For sure. Maybe in no particular order, materials. And, lots of fascinating work in material science and chemistry on new polymer formulations, new alloys, and also the intimate connection between the material and its processability through 3D printing. And I think we're just scratching the surface. Right? Now we're all about making parts with consistent microstructure and high quality and predictable mechanical properties. But from a metallurgy perspective, there's a whole world yet to be explored. That is, it's not just the material science, but it's the computation to be able to derive the design of the part, and then the machine controls and automation and monitoring to be able to actually qualify the part. And I really see a lot of great things happening there.
So all over the place, but especially software you mentioned.
Software, right? Yeah, design tools, and there's lots of great progress across the field in generative design, topology optimization, whatever you call it. Also, just like more efficient ways to represent solid geometries, so you can do things more interactively. I think that interactivity is really important, right? A lot of the process of going from a design to a 3D printed part will be more automated, more smooth, even creating that design. But the human element, in my opinion, will never drop out, and we have to better understand how the human element engages with these new design interfaces, right? To be able to express our creativity or know how to bring this very complex process space and design space to the human in a way that we can understand and make the best use of.
So it's easy, of course, for a 3D printing person to sort of dump on machining, but it feels like machining has become a stable discipline, right? You can go to IMTS every 2 years and see incremental improvements in everyone's specs on their mills or their lathes. Yeah. Do you think 3D printing will ever reach a kind of maturity like that, or is it simply too broad and too deep a field with too many flexible inputs, and it'll just always keep developing and always keep experimenting with new materials and new software processes for coming up with designs?
Yeah, so that's a fascinating question. I think that the core process technologies, for metals, for polymers, they'll reach a state of maturity where I think this is a great kind of research question, like they sort of reach their asymptotic performance, maybe like where machining is now. You're able to access capacity of that 3D printing technology at some leveled cost. But we're still early, and you talked about sort of materials diversity and making exotic things, right? I think that really exciting exotic areas in bioengineering and medical devices, right? Stuff for the body, inside the body, manipulating cells. There's a lot of stuff there. printing materials that change their shape, that kind of stuff. Those are the more areas we're going to see. That the basic science, I think, continue for a longer term, where primarily the stuff on the show floor here at Formnext, I think it's all about industrialization, right? And you'll see machines that are faster and better and more cost effective, and bringing the robots to unload the machines and so on and so forth. I feel like you can kind of see that happening. Maybe the picture is not crystal clear, but it's all going to happen. It's really exciting that it's going to happen.
So, as you mentioned, we're sitting in the foyer outside of the main hall at Formnext. Has anything surprised you this year? Anything really struck you about what you see at this trade show?
I think overall it's just great to see more progress toward industrialization. More exciting examples, more integrated tool sets. That's software, that's printing machines with embedded sensors. That's also post-processing equipment, as well as sort of spots here and there. More activity from China. Right? I see more Chinese companies, and knowing what China does in manufacturing, I'm convinced they'll build their own additive manufacturing industry, and it will thrive in some ways, with the rest of the world, and other ways on its own, because they're a very, very large country and large economy. Announcements here and there from machine companies, always exciting to see. Maybe there hasn't been a breakthrough that struck me, but that's not a negative, right? I don't know if we need a breakthrough now. Put our heads down and do what we need to do to take things to the next step.
Need a lot of good incremental improvements.
Yeah, right on.
So I'd like to ask you the question I ask everyone who comes on this podcast. Tell us about your favorite tool.
Sure. So I'll give you a communication tool. When I teach, when I create videos for teaching online, as well as in the classroom, I use a camera. It's an Epson document camera to view manufactured objects live. So projected on the big screen or captured in 4K. And that adds such a visual interactive element to my teaching. I can't imagine how my teaching of manufacturing, which is all about the fundamentals and the artifact, I can't imagine how it would be without the document camera.
So it's a huge step up over the old transparency projector.
Yeah. Transparency, not quite. I haven't. I came into teaching, I think, sort of just after the transparency generation left. So
I was just remembering that with someone in the sight of your teacher using like a Kleenex and some alcohol spray to wipe off the transparency projector and start writing something.
And then there was the roller of transparency.
That's right.
You could roll it back and forth and then wipe it all at the end of class. Yeah.
So digital transparency projector.
Yes.
Awesome. It's been a pleasure to speak with you today. If listeners want to find you online, where should they look?
At MIT, the Department of Mechanical Engineering, my email is ajhart@mit.edu. Feel free to reach out. And also we're launching a new additive and digital manufacturing research center called ADAPT, and that's adapt.mit.edu.
Excellent. John Hart, thank you so much for joining me.
Thank you.
If you'd like to learn more about the people you heard on this episode of the podcast, take a look at the show notes. We publish some notes with every episode of the podcast on our blog, and you can find a link to that by looking at the notes in your podcast player. Also, take a look at the Digital Factory report. If you haven't read it already, you can download it for free at thedigitalfactory.com. For the Digital Factory podcast, I'm John Brunner.